All right, Nick, we are going to talk today about functional programming. How's it going?
Hey, yeah, I'm doing really good. This is a topic I'm really passionate about, so real happy to talk about it.
Awesome. Thank you for taking some time today. So, I know one thing in the JavaScript world is that functional programming in the last couple of years has become extremely popular. I know I'm an Ember, I do a lot of stuff in Ember.js, and there's a lot of thinking about how we structure our apps in more of this way. Can you explain what functional programming is?
Sure. So functional programming is a paradigm, a programming paradigm, very orthogonal to object-oriented, and it's about the way, like the meta way that you structure your programs. So there are a few things that makes a language functional, but what it boils down to is that functions are your base unit of logic, as opposed to like a class or an object, and like your Java or C Sharp.
So there's a lot of crazy things with functional programming. There's terms like monads. Like what the heck is a monad?
Yeah, so one of my big qualms with the functional program community is everyone likes to use really esoteric words to make it just to raise the barrier of entry. I'm not sure if that was like the intention behind it or if it was just everyone or like PhD guys that came up with it, but it's really I think destructive, and people like us in the JavaScript community, as we begin to adopt these patterns, I think the onus is on us to fix it. Monad is sort of a great example of really bad naming conventions. Um, it's sort of hard to explain in a dynamic language because it relies heavily on a statically typed system to explain a monad. But I think like the easiest way to understand it is a way to generalize and abstract common like computational patterns. So a really easy example is what's called the monad. And the maybe monad. And what the maybe monad does is like explicitly says that you have something, a value that can be a value or it can be nothing. So in JavaScript, if you're dealing with, maybe like a SQL lookup that could return nothing if it's not there, or maybe an API response that could return a 404. So it's either going to give you some data or it's going to give you nothing, right? And you would see like an if chain, especially if you have like a lot of these. You would say like, if this is true, do that, else do this, and you get like the pyramid of doom as these if statements sort of bundle out. And the maybe monad, is sort of like syntactic sugar over that, where you can just say, okay, this value is a maybe object, so it's either an object or it's nothing. And it allows you to avoid that pyramid of doom and compose them really nicely with some of the monadic operators.
Yeah, it sounds very interesting. I think I understand what you're saying. I know you wrote an article on it as well on your blog, which we'll link in the show notes as
Yeah.
well. So I know another part of functional programming, a lot of people talk about immutable data. What is that and why is it important?
So immutable data is really important for a lot of different reasons, especially when you're dealing with like state, like objects or like application state. In the front end, now as we are moving into these like single page applications, and there's so much of the logic and the state that happens on the front end, it's really important. So this is why you see frameworks like Redux or NGRX or Relay come up as a way to manage it, because it's too crazy if you're trying to deal with all the state right in the same place as your presentation logic. And immutable data is a way to deal with state in a sane manner. What happens a lot of the time when you're dealing with mutable application state, if you have one method or one class that is changing something, and you have another method or class that's dealing with the same state, to understand how they work together or how that state affects the app, you have to understand how everything that is touching it works, right? Which is, as your application gets larger, it's sort of like exponential cognitive load, right? Becomes really hard to understand. You have to go through 15 different files to find the one method that changes it and understand all of this holistically before you can actually make a change that you feel safe about. That's not going to just break everything. Um, of course, this all becomes more important the bigger an application gets. Immutable data basically is, if you say a value x is equal to the number 2, it is 2 forever. X will never be anything else. You can never say x is equal to 3 or x is equal to 4. It's just 2 because you told me x was 2. You're not going to lie. You're JavaScript. And what this allows us to do is we deal with state as sort of, if you can imagine it as a stream of the changes, and then you can map your presentation sort of relationally to the stream. This is where like functional reactive programming comes. A lot of people talk about observables, like RxJS is getting really powerful and important. So this is all are sort of built on the idea of immutable data.
Yeah, I know that Elixir also has this idea of immutable data. You can't just copy one variable to another. You have to copy it to a whole new array, a whole new variable for you can do things, and it makes for some interesting programming when you're having to do a lot of manipulation. It also uses a lot of for eaches or that map and
right, your high order functions. And that's sort of a good point to bring up because this is what makes functional programming different than other languages. I sort of glanced over it earlier, but there are a few tenets that like a true functional language has. JavaScript satisfies some of these, but it's not on the same level as an Elixir or a Haskell. So one is immutable data. Like we said before, it really adds clarity to a programming language. It's a lot simpler. There's a great talk by Richard Hickey called Simple versus Easy. I really think everyone should watch it if you're interested in just being a better programmer in general. And he talks about his idea of simplicity as single-threaded. It's not tangled or coupled with anything else. So it might not be easy, it might not be approachable, but it's simpler. And immutable data really does that for our programs. The second thing is pure functions, which means that functions that are free of side effects. So you're not doing any console logs or any SQL queries or HTTP requests. You give a function data, and it returns some other data. So as long as you give it the same data, it should return the same result every time. And what this lets us do is think of functions sort of as map lookups, which makes it really easy for optimization because you can memoize stuff. And it also is easier from a cognitive perspective as well because you see a function, if I give it X, I'm going to get Y every single time. And this consistency is what is really important in functional programming. So those functions. Pure functions, immutable data, and of course functions as first-class citizens, which means that we can have a function that takes a function and returns a function. The famous example in JavaScript is like your for each or map that they take a function, an array, and they map that function over the array and return you a new array. But you also can have a function like memoize, for example, from underscore. I don't know if you've worked with that, but that'll take a function and memoize it and return you a new function that it has that memoization built in.
Sorry to interrupt you. You mentioned basically high order functions, right? So functions that can take other functions.
Yeah, this is something that is starting to be widely adapted everywhere. Like Java 8 now has lambdas. C# has had them for a really long time. Pretty sure you can do that in C++ as well. And this is an example of higher levels of abstraction that you can get to with functional programming. Because when you can treat functions as small, like discrete units of code, you can build them up and memoize them, or have a logging higher order function that will put logs in a function. And it allows you to sort of abstract sort of your extra needs away into like constructor functions and manipulate it that way.
Yeah, that's interesting, this memoization, being able to remember what was put into the function before.
Yeah.
If I remember correctly. Do you think, so one last question. This is kind of just a taste of functional programming to get people interested in it. So there's different types of inheritance in JavaScript, and there's functional, I guess there's prototypal inheritance.
Prototypal, yeah.
Prototypal, as I can't pronounce it, inheritance. And there's different ways you can learn JavaScript. Do you think learning functional programming would be the best step? I mean, and with ES6 now we have classes too, so you can try to learn JavaScript in that purely object-oriented fashion. But that doesn't seem quite right.
So one thing to note, and a lot of people stumble over this, is the class keyword in ES6 is not inheritance like from Java or C#. It's still prototypal inheritance. It's just syntactic sugar over it. That's a question that comes up a lot in interviews. Like I think every interview I heard that because it's a big tripping stone for people that are coming from, a strong object-oriented background. As far as functional programming versus OOP, they're both important. I like functional programming, but I'm not a zealot. It's all about picking the best tool for the job. I think that functional programming is better in more cases, but that's not to say that you don't need to understand both of them. Although that being said, I think we can sort of see the JavaScript community moving more into a functional direction, especially with your React and Redux. So I would be very good at it. Know both of them, but I think probably be better at functional, if you're going to not be even.
Yeah, and that really helped you when you were looking for a job too.
Yeah, it was a big help for me.
All right. Well, thank you so much for giving us some time to talk about functional programming. So where can people reach you at again?
You can reach me on my blog at blog.nickspinosa.com or on Twitter at NickSJS.
Awesome. Thanks, Nick.
My pleasure.